Okay, in this video, we will find out the T critical values using the easiest method, in which we'll be using this website, geogebra.org/classic hash probability. Please bookmark this if you haven't done it, and it's very, for at least for introductory statistics. Right, so here this question is only about finding out the T critical values. Okay, we won't be finding out the confidence interval. If you want to find out the confidence interval, then please follow this link over here. You will have an idea. Okay, so here determine the T critical value is T alpha over 2 for a confidence interval with a confidence level of 90% with a 24 degrees of freedom, 94% with sample size 33, population standard deviation is unknown, 98% with sample size, only sample standard deviation is known. Okay? So here, let's head over and let's start working on this. Question A, it's simply saying 90% with degree of freedom 24. All right, so that looks fine. So here 90% means, first of all, we need to find out what is alpha. Okay, so alpha is 1 minus 90%. 1 minus 90%, you might want to write down this as 1 minus 0.9, which is simply 0.1 or simply 10%. And we know that we need to figure out what is alpha over 2, right? That's what we need to do. And alpha over 2 is simply 0.1 divided by 0.1 divided by 2, 0.5. Okay, so that looks good. Okay, then what is T alpha over 2? Let us work this out. So if you have a distribution, something just like this 0.05 with either this one, this shaded portion, or this shaded portion. Okay, basically we are saying that this T alpha, or sorry, alpha over 2 is 0.05, and here this shaded portion, the blue shaded portion. Okay, we are trying to find out that for 90% confidence interval. Okay? So for that, we need to figure out the T values. Okay, so now let's head over to 24 is the degree of freedom. So let's head over to this website, geogebra.org/classic that has probability, and click on this drop down menu and go for student distribution. And degree of freedom, we already know that that's 24. Okay, and you can either choose this left-sided tail or right-sided tail. Okay, so it's both of them will give us the same thing. We just need to ignore the positive or negative sign. That's all. We just need to go for numerical values. So I am choosing the right hand side, and here we need to write down in this space. Okay, since this is the space for probability, 0.05. Write that down. So that would be 1.710. 09, 1.7109. So this is 1.71088. All right, let's write that down, or simply 0. So this is the T value for 90% confidence. Okay, so to find out the confidence interval, 90% confidence interval, what you will do is you'll simply go for x bar minus error based mean. Error based mean is simply T alpha over 2 times sample standard deviation divided by the sample size. Okay, that's the left endpoint, and right endpoint would be x bar plus T alpha over 2 times S over root n. Okay, this formula. Okay, so that's it for A. Now I won't be talking too much about this one. Question B. Question B is 94% with sample size 33 and population standard deviation is unknown. So for we know that for student distribution, the population standard deviation is usually unknown. Okay, so that's why we go for that. Okay, so we go for student distribution. All right, B, 94% confidence interval, sample size, or that's n equals to what? N equals to 33. Then degree of freedom is simply n minus 1, which is 33 minus 1 equals to. Okay, so that's fine. Now 94% confidence interval means we need to figure out what is alpha. Alpha is 1 minus 94%. Simply 1 minus 0.94, simply 0.06, right? That's 6%, right? Okay, so then alpha over 2 is 0.06 divided by 2 equals to 0.03. Again, the same thing. If you have this distribution, again, I'm saying the same thing over and over again. So these two are the points where this 0.03 is this blue shaded portion. Okay, this is the area alpha over 2 0.03. Okay, on the right hand side, the right tail or the left tail. Okay, so alpha by 2, 3. Now once we have done that, we also know the degree of freedom is 32 and 0.03 is the area of the probability, either on the left tail or the right tail. So let's head over to the same website, and degree of freedom now here is 32. This time let's go for the left tail. Okay, it's actually the same thing. Okay, and we would like to go for 0.03. That's 3%. So that's it. Okay, so we ignore the negative sign, we just go for the positive sign. 1.94987. This is 1.94987. Okay, so that's the t value. If you want the demonstration that the right tail, the t value that we get from the right tail and left tail are the same, then you may want to go for the right tail and write down the probability over here in the second box, input box. Okay, 0.03, and look here, you are getting the same thing. Okay, minus except the numerical sign. Okay, we ignore the plus or minus sign. Okay, so that's it.